Okay. So wrapping this up is 6.5. And right now, you guys are familiar with how to use the 3 trig ratios to find missing angles or missing sides in right triangles. Okay. And you're also able to do some word problems when you're given a diagram or you're given angle of elevation, things like that. One last thing I want to talk about where we can apply this is when you are asked to solve a right triangle. Okay? If you are asked to solve a triangle, that means find the measures of all missing sides and angles. Okay? So you're not, with the trig questions we've done so far, you were asked to find one missing angle or one missing side. Here you'll be given some information about a right triangle and you'll be able to find all the missing angles and sides. So you want to think of 3 things to do when you're asked to solve a triangle. Trig, the sum of 3 angles in any triangle is always 180 degrees. And Pythagoras, a squared plus b squared equals c squared. You can use all 3 of those. Okay? So let's look at a couple of examples. We're asked to solve this triangle. Okay? So what we're missing is side xz, so we've got to find that. We've got to find angle x, and we've got to find angle z. So there's 3 things we have to do in this one. So, I don't know, let's start with the angles. What kind of math do you think you would use to find angle x? Trig, Pythagoras, or the sum of angles is 180? Well, we're finding an angle, so Pythagoras is useless. Sum of the angles, but I don't know 2 of them, right? So trig is the only thing I can do. So let's start with x. Therefore, this side is opposite. This side is adjacent. So OA mean TOA, which is tan. What does my equation look like? Tan, then what? X equals, yeah, 10.0 or just 10.6, fine. So we got that. All right, how do we solve? How do we find the missing angle in trig? Inverse, always. The only time you use inverse is when the angle's missing. And notice we're asked to round our answer to the nearest 10, so 1 decimal place. Anybody got it? 59.0. Okay, so that's one of the 3 things we have. Let's look at angle sec. Now we've got some choices. I could do trig again. Or, now that I know 2 of the angles, I know this is 90 and this is 59, and all 3 of them add up to 180. I could just do this. 180 minus the 90-degree angle minus the 59-degree angle we just found. And when you do that, you're going to get 31.0 degrees. Okay. You could have used trig, you could have used tan again. This time it would have been tan z equals 6 over 10. And then solve from there. You'd still get the same answer. Okay. Finally, the missing side. Now I got tons of choices. Remember, I know that this is 59.0 degrees now. I know that this is 31.0 degrees. I could use trig. I could use Pythagoras because I know two of the sides. So a squared plus b squared equals c squared. What would you like to do? Slow down. It's hard to hear everybody all at once. Come on, pick one. Pythagoras. Okay, thank you. So this is a leg. This is a leg. We're finding the hypotenuse. So therefore, using a squared plus b squared equals c squared. Well, one of the legs is 6.0 squared, plus the other leg is 10.0 squared, equals, it's no longer called c, it's xz squared. All right, 6 squared is 36, 10 squared is 100, so if I add the two, I get 136, equals xz squared. How am I going to find just xz? Square root 136.0. And round that to the nearest 10. And if you do it correctly, we should get about 11.7. Don't forget there's units in this one. Centimeters. So we've solved the triangle. Okay. Okay. Let's look at another one. What are the missing things I have to find? Angle D.
B
B to E.
and F to E.
And F to E. Okay. What do you want to go for first?
Angle D.
Angle D, sure. I could use trig, but I need to know two sides, don't I? To use trig. Or I could use three angles add up to 180. Since I know two of the angles, I can find angle D by doing 180 minus those two angles. And I get 65 degrees. Okay. I guess it doesn't really matter which side we find first, so let's find DE. Here I actually have, well, I mean, I had no choice as to what kind of math I have to do trig. So what would you like to do? We could use this angle or we could use this angle. Let's use this one. So if I'm using this angle, what's the name of the side that I know? Opposite. What's the name of the side I'm trying to find? Hypotenuse, which means OH, sine. So sine of the angle, which I'm told is 25 degrees, equals the opposite side, which I know is 5.0, over the hypotenuse, which is what I'm trying to find. Okay? How do I start solving this? Times 5 dE. That gets rid of the fraction. So I'm left with dE times sine 20, you don't need the parentheses. Times sine 25, those dE's cancel, equals 5. Still don't have dE by itself. Divide by sine 25. So now I know to find dE using my calculator, I have to divide 5 by sine 25. And I believe we're asking, there's 10th again, yeah. Anybody got it? 11.8. Good. Okay. And finally, the other missing side. So I know that this is 11.8. Lots of choices now to find FE. I could use Pythagoras because I know two of the sides. I could do trig again. Let's do trig again. Let's use this angle and this side to find. So if I'm using this angle, this is called the, this is called the adjacent. So opposite over adjacent. 10. So the tan of 25, so this is the prime FE. So the tan of 25 degrees equals 5.0 over FE. And I have to do the same kind of algebra that I did with DE. 2 steps. I have to multiply both sides by FE to get rid of the fraction. So FE times tan 25 is going to equal 5.0. And then I have to divide by tan 25 to figure out what FE is. Okay. Anybody got it? 12.8? 10.7? I need a third person. 10.7? I think it's 10.7. Okay. The last question is kind of like a word problem with the diagram. So again, we're sort of using our knowledge of different types of math. So I need to figure out the perimeter of this rectangle. How do you find the perimeter of a rectangle? Add up all the sides? Or can't I just go 2 lengths plus 2 widths? Right? 2 lengths plus 2 widths gives me the perimeter. Well, I've got some work to do. I've got to find this, and I've got to find this before I can use the perimeter formula. So let's find FG. What kind of math do you want to use? Three. Because look at this right triangle here. Don't look at the whole rectangle. Notice the right triangle. So if I want to find FG, what's the name of side FG? Opposite, adjacent, or hypotenuse, looking at this. Adjacent. 10.7 is hypotenuse. So that means coast. So cos 28 degrees equals adjacent FG over hypotenuse 10.7. This one times both sides by 10.7. And that will give you FG. So 10.7 times that gives me 9.4 centimeters. Now we got to find GH. Let's use trig again. So I'm given this angle, name of this side. Set this side. Still the hypotenuse, which means I'm going to use sine this. So sine 28 degrees equals GH over 10.7. And once again, to get the missing side by itself, I multiply both sides by 10.7. I get, should get 5.0. So now I've got the length and the width. Now I can use the perimeter formula. So the perimeter is going to be 2 lengths, or 2 times 9.4, plus 2 widths, or 2 times 5.0. So I multiply each of those and add them up, and I should get 28.8, don't forget the units, centimeters. Okay. Okay.